Hi everybody, this is Mr. Kinney with period 4. Most of the students are gone right now because they're at the every 15 minutes activity. So we're working on what I've been calling the heat sheet. No, this isn't the heat sheet, this is the specific heat paper. And we're working on the first few questions. And question number 1, we've got it set up right there. And it was pretty straightforward. We have the base equation, and then as reading the problem, we've got 0.5 kilograms, then times 900 joules. We found that from turning this paper over and looking on the specific heat chart, paying attention that this chart has kilograms instead of grams. And then the problem just told us the temperature change was 7 degrees. Would you shut that door for me, please? Now, we're working on question number 2, and the same, thank you, question number 4, and we're looking for heat, which is the symbol Q, is still mc times delta T. In the problem, they told us we had, let me come over to this one. There we go. Make sure we can see it all. It says we have 100 liters of water, and they gave us information that 1 liter of water is 1 kilogram, so we just figured out that the mass will be 100 kilograms of water. Then we need to find the specific heat for water. And ladies and gentlemen, what is the specific heat for water when you turn over your paper?
4,180.
4,180.
Okay, now, 4,180 joules. Now we got to be careful per kilogram.
Oh, it's 184.
Oh, sorry. This is 4,184. My mistake. Sorry about that. 4,184.
Yeah.
There we go.
That's right.
Yeah.
Joules, and that's kilogram degrees Celsius. This is a physics chart. So they got kilograms instead of grams. And our change in temperature, we're going from 10 to 25. So delta T will be 25, because that's the final temperature, minus 10. So what's that going to equal? 15 degrees Celsius. And now to get the answer for this problem, it'll be 100 times 4,184 times 15. The answer will be, we'll cancel out the kilograms and the degrees Celsius. The answer will be in joules, and it's going to be pretty big. What's the next one I asked you to do? Question number 5. Now this problem is asking you what is the specific heat. And from our specific heat chart, specific heat is the ability to absorb or transfer energy.
Can I go to the bathroom now?
So, specific heat, we're looking for C. So we've got to rearrange our base equation. Well, this is a part you need to be here for, because if you cannot take our base equation of Q equals mc delta T, and we need to get C all by itself.
No, I know how to do that. I just don't know how to plug stuff in.
Well, we're going to divide each side by m times delta T. And delta T cancels out, the M cancels out, and it looks like specific heat will be Q, the number of joules, divided by the mass, divided by delta T. So now that you got the base equation that you need, now we're just going to go through and fill in the blanks. So Q in this problem was 1,500 joules. Now, if it gets to this point and you don't know what to do, you need to go through and review your notes. You need to know that Q is the abbreviated symbol for joules. M is for mass in either grams or kilograms. In this problem, it's 0.12 kilograms is our mass.
We can't see it.
Thank you. There we go. And then we've got to divide it by the change in temperature. And this problem said we went from 45 to 40. So 45 to 40. So what is 40 minus 45? Wait a minute. 240 minus, 40. We started at 45. So what's the change in temperature? What is 40 minus 45?
Negative 5.
Negative 5 degrees degrees Celsius. So this would be negative 5 degrees. So now at this point, when we divide this problem out, we're going to have 1,500 divided by 0.2, which will tend to make this number really big. And then we're going to divide it by 5 and just change the sign. So let's see, 1,500 divided by 0.2 will equal a big number. We're going to divide that by 5. And I don't know on this calculator, there's the change sign number, -5. So our answer comes out to be negative 2,500 joules. What does the negative mean? Was this reaction releasing heat to the surroundings, or was this taking heat from the surroundings? It's when we get a negative sign, that means the system is losing heat. So the system losing heat. Oh, it's supposed to be losing heat. That's why we get that negative number. Now the joules, it was 2,500 joules is what we were looking for, but the negative tells us that this was, now if it's a negative number, if the system is losing heat, is that endothermic or exothermic?
Endothermic.
If the system is losing heat,
Exo.
it's going to be exothermic. Negative means it's losing heat, and we're going to feel hot, and it's going to be exothermic. Destry. What's the next question I asked you to do?
6.
Number 6.
Do you want me to go to my bathroom?
So number 6, I'm not going to work through all the math like we did before, just how to get it set up. So number 6 tells us that what is the specific heat? So we're looking for C again, and from our previous problem, that's going to be Q divided by M times delta T. And I'm reading the problem now. You can't see it on there. Material that gains 600 joules, so this will be 600 joules. No, I'll put it down there, 600 joules. Then we got to divide it by the mass, and in this problem it says it's 0.25 kilograms. Oh wait, I misspoke slightly in this problem right here. The answer is not going to be 2,500 joules because we're looking for C. It's going to be 2,500 joules divided by kilogram degrees Celsius because we're looking for a specific heat. So we're looking for the heat capability there. And then change in temperature in number 6. It was increases by 3 degrees. So we've got 3 degrees. So now it's, well, let's see, I'm going to cross 3 off with that. That becomes 200. 200 times 4 is going to be around 1,000 because when you divide by 0.25, you're like multiplying by 4. What's the next question I asked you to do? 7 was the next one? Okay, so for question 7 on our paper, we're looking for liquid with a specific heat. What is the mass of the liquid? So we're looking first off in number 7, we're looking for mass. So we need to take our base equation, mc delta T. We want to solve it for just mass. So we need to divide by the specific heat, or C, and get rid of delta T. One thing, this is specific heat. It is not degrees Celsius, and it is not calories. In this unit, a C by itself means specific heat. If we're talking about calories, our abbreviation needs to be CAL because we don't want to get things, we don't want to get you, it can be confusing with all the C's. So let's see, cross that off. C, so it looks like, and we got to divide by C delta T here. So now mass is equal to Q over the specific heat divided by the change in temperature. In question number 7, they tell us that, let's see, first off it tells us 4,750 joules. We got to divide that by the specific heat is 1,900 joules. Now I'm going to put the kilogram degrees Celsius up here in the numerator, so it gets flipped up there. Then we got to divide by delta T. We went from 20 to 30 degrees, so 30 minus 20 is 10. Celsius cancels, joules will cancel, and our answer will be 4,750 divided by 1,900, and then divide that again by 10, and you'll get some answer. And at that point, what's the last question I asked you to do? Oh, the next one?
8.
Okay, number 8. Again, I think number 8 I had it set up. You're looking for delta T. Let's see. Oh, we're looking for mass again. Now look, I'm not going to go over this now. We're setting it up just like we did number 7. You're going to use Q is equal to C times delta T. Now you just go through and fill it in. If they don't give you the specific heat, you turn over your paper and look on the data table. What's the next question I asked you to do? Which one?
11.
Now, number 11, and this is the last one I'm going to go over here. It gives you some information. 0.25 kilogram of aluminum, so we may need to look up aluminum specific heat on the front. Here's the number of joules that it changed. What will be the change in temperature? Okay, this one's pretty easy. We just need change in temperature. We don't need initial or final. So our base equation is Q equals mc delta T. We want delta T by itself. So divide by mc. And delta T will be Q, which in this problem, it's 5,000 joules. Divided by the mass, which is, boy, this question sheet seems like 0.25 kilograms. Okay. And then we need to divide that by the specific heat for aluminum. Let's see. Aluminum, we need to divide by specific heat, which is 900 joules kilograms degrees Celsius. I found if you're asking me how I found the specific heat for aluminum, I just looked on my chart of specific heats. Here's aluminum. Okay. Keep it in mind, pay attention to the units that they're in. So 900 joules, and then since this is in the denominator, we're going to put kilogram degrees Celsius up there. And now to get the answer for this, you'll have 5,000 divided by 0.25, which basically makes that 5,000 times 4, which is going to be like 20,000. End up being 20,000 divided by 900, which you can cancel off those zeros. So 200 divided by 9 will be your answer. And that's going to be in degrees Celsius because we're looking for delta T. What was the very last, the next problem? 12. Number 12 is set up just the same way. So I'm stopping the video. Get that over there so you can see it. So that's how you set these problems up. Just get your base equation, rearrange it, and say goodbye.
Bye.
Bye.